Alright, in this video I'm going to go over how to do the basics of graphs. You need to be comfortable making graphs, whether it's on paper or in Google, and I will show you a video on how to do it in Google. You also need to be comfortable interpreting graphs. That takes a little bit of practice, and so does graph making. Choosing what type of graph and interpreting graphs, that takes practice. I'm going over that with you this year. We'll spend time on it throughout the year because it's a skill that you really need to know in college, and a lot of students come in not having much experience with graphing. So let me in this one go over the basics of making a graph and then choosing between a line graph and a bar graph, which also takes some practice. Alright, a graph. You got to have graph paper, either using Google, which will automatically do it for you, or graph paper. Do not do it on regular paper. You have your x-axis down here, and you have your y-axis here. How do you choose which variable goes where? Your independent variable is going to go on the x-axis. So remember your definitions of independent and dependent. Okay. And then your dependent is going to go on the y-axis. Now you have to label each axis. So when you're working in Google, Google does not automatically do that. So you need to make sure you're going to add the labels. So make sure you label the x and y axis. They also must include units. So meters, seconds, liters, milliliters, okay? And it needs to be metric unless I specifically tell you we're not using metric. So you have to put the label here of the independent variable on the x. The y-axis is going to be the dependent variable. And you must include units in parentheses so that everyone knows what units you used. Because did you use inches? Did you use centimeters? It's going to make a big difference. Okay. You also must have a title. The title, again, takes some practice making up titles. There's not like one set right title, but the best way to start is to use the independent and the dependent variable in your title, and then add anything you might need. Don't just use the independent and dependent variable, like height versus, let's say it's height versus age. You need more than that, okay? So height versus age of men 18 to 25 years of age, something like that, okay? So you don't want it long, but you want it descriptive. It should describe, when someone reads the title, they should know what your graph is going to be about. So again, you need to practice this, and we will as we make several graphs. Okay, so you got your independent, dependent variable. You might hear a train in the background, but we're in Vincennes, so what do you expect when my windows are open? And then you've got your title. Now, when you do a graph, each little box that you're using here must be the same or equal increments. So let's say we're just doing a simple 1 to 10. It has to be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay? Or you could go 2, 4, 6, 8, 10. But each of these boxes has to be worth the same amount on this axis as well as this axis. So you can't go 2, 6, 8, 24, okay, 36. You can't do that. Each box must be worth equal increments on both axes. Okay. So what you have to do is you have to look at your low number and your high number, and you have to make sure that you have enough boxes going up in equal increments to cover from your low to your high. Okay, from your low to your high number on both axes. Now Google will do that for you. Okay, so when you're doing it on Google, that is something it will do automatically, but you always want to check it. Okay, a line graph. A line graph, well, let me start with a bar graph. All bar graphs must start at 0. Okay, all bar graphs must start at 0 and go up in equal increments. Okay, you have to start at 0. I will show you an example, or we'll talk about an example. If you don't do that, you distort the graph. Okay, the graph is distorted with a bar graph if you don't start at 0. So even if your first number is 100, you have to start at 0 and then maybe go up by tens, but you have to start at 0 and go up in equal increments on a bar graph. A line graph. Let's say your first number on this axis is 100. You don't need to go 0 and then go all the way up to 100 so your line doesn't start until here. What you can do, you can put a little squiggly line in there, and I'll show you examples of that, and then you can start. Let's say your first number is 100, and you're going to go up by tens. You could start get rid of the 0, and then go 90, 100, 110, 120, 130. So you don't want to waste a lot of space in a line graph. You want the line to start reasonably close to here. So again, you don't have to start at 0 on a line graph. You can start wherever and go up, but you still have to go up in equal increments. Okay, so line graph, don't have to start at 0. Bar graph, you must start at 0. And then you need to include a key if necessary. So let's say we have 6 lines on this graph. You need to know what each line represents. Okay, and I don't want you drawing a line and at the end of the line writing this line is this and this line is this. I want you to have different colors or something to distinguish them, and then do a key on the side that says this color equals this color equals this, and so on, so you know what each one represents. Again, Google will help you with that. It will not do it completely correctly, so you will have to correct that as we go along. Okay, so that's the basics of graphs. Let me go over line graphs and bar graphs with you. Okay. All right, how do you choose which type of graph to use? I'm going to give you some hints. There's nothing set in stone. Many graphs can be done 2 ways, but what you have to think about with the graph is what is the simplest way to show or represent data. You don't want a graph to be so busy that people don't understand it. Okay, you want to understand it. So many times bar and line graphs can be used interchangeably, but one works better than the other. Okay, but there are some givens here. So let's talk about a line graph. A line graph is always used, almost always used, when you're tracking changes over a period of time. Okay, over a period of time. So if you're measuring the same thing over time, like how many blades of grass you put in grass seed and how many blades of grass has shown up over every day. So every day you record the number of blades of grass that you see growing each day. You're measuring the same thing, blades of grass, over time. Okay, so through time, line graphs do the best job of showing this. Okay. They can be used to compare changes over the same period of time for more than one group. So again, if you have several lines, that is fine. Okay. When you're looking at a line graph, is there a relationship or connection among the points? Are you measuring the same thing over time? Okay. And if you're doing that, then it should be a line graph. All right, so this is looking at sulfur dioxide, which is a air pollution. It's also a climate change. It contributes to climate change. It's a greenhouse gas. So what you have here is you have time. Now notice we're marked here in year. Okay, you have the emission, and technically this would probably say emission of sulfur dioxide if you want to be more correct. And then notice there are units here. So we're measuring the same thing over time. Okay, over time. So you can use a line graph and you connect the lines. Now it's not always going to be a perfectly straight line. So this line is this. It's a line graph because you're connecting points, but it's over time. Okay, over time. And here's your title. Okay, air pollution and sulfur dioxide emissions over the years. Very simple title. When you read that title, you know what the graph is representing. And again, it is over time, so you're going to use a line graph. Now, would a bar graph be completely incorrect here? No. Would I take off points? Yes, because it's over time. So we're going to set some basic rules to get you started on which type of graphs to use. Here are other examples. Here, the number of reproducing E. coli bacteria over 10 hours. We're measuring the same thing, number of E. coli over time. Okay, and you got the units here, number of E. coli bacteria. Okay, so you're just counting the number, probably in a petri dish. Here you have the effective UV exposure of the appearance of mutant cells in 3 different bacterial populations. So notice here's the key. Okay, so we know what each line represents. Here are you, and I know it's hard to see, here is the number of time in minutes. Again, you got units here, and then the number of E. coli. Okay, so line graphs, that one's pretty simple. Okay, when to use a line graph. You're measuring the same thing over time. All right, bar graphs are used to compare things between different groups. You may be measuring the same thing, but you're measuring it in different groups. So comparative data. Okay. This type of chart is one that's more familiar options and easy to interpret. Easy to display. You can use it over time, but for us in here, let's just say no. If it's a time thing, you're going to use a line graph. That way, again, as you get more advanced in this, you may look at little idiosyncrasies between graphs. All right, so the composition of lunar soil. So the astronauts brought back soil from Mars, or the moon in this case, and the relative concentration. Right here, you're measuring the same thing. It's all lunar soil, but you're measuring different elements, okay? The percentage of different elements. So again, here, there should be something here that says elements of, that you even could say just elements, okay? Because you're measuring the elements, but there should be something here saying what this group is, but they are different elements, okay? So different elements, each one's going to have a bar. In this case, you don't need a key because the key is right here, okay? You know that this one is oxygen. You could technically make these the same color. It doesn't matter. Or different shades. You could put in lines here and circles here. It does look better when you make colors like this, but technically it doesn't have to, okay? So there should be something that says elements here. Again, you're measuring different things. If you connected them and did a line, it makes it look like you're measuring the same thing, that there's some direct connection between them, and there's not. Oxygen and silicon are very different, okay, different elements. All right, I will do this one in the next video.